Hello everyone, welcome. In this session, we are going to learn the relationship and the difference between AI and neural computing. Upon completion of this video, you are able to learn the basic definitions of the following four concepts. They are artificial intelligence, machine learning, neural computing, and deep learning. You will understand what a Gulf AI is. You will also learn a rule-based system called Shadowloo Chatbot, which is a typical example of AI but not machine learning, and support vector machine algorithm, which is an example of machine learning but not neural computing. Finally, I will also show how neural computing and machine learning are related, and how to choose between them. Artificial intelligence is ubiquitous. It has played an important part in our daily lives. There are many real AI applications today. For example, Chatbot uses AI technologies to simulate human-like conversations with users to provide answers to users' questions. AlphaGo applies AI algorithms, which has become the first program to defeat the world champion in the game of Go. Table tennis robot driven by AI is acting as a coach to train players in the table tennis game. Self-driving cars use AI to travel between destinations without any human operator. Therefore, AI technologies have been changing our society and economy. In the new era of AI technology, companies and developers around the world are often talking about artificial intelligence, machine learning, and neural computing. Sometimes these three terms are often used interchangeably. It is important for us to understand that these three terms are all part of AI umbrella. Nevertheless, there are some subtle differences among them. Firstly, let's look at the difference between AI and machine learning. Artificial intelligence is a very big and broad concept that covers everything related to making computers smart to mimic human behavior. In comparison, machine learning refers to the AI system that can self-learn based on the statistical algorithm without being explicitly pre-programmed by humans. Therefore, we can see that machine learning focuses only on a part of AI systems that have the ability to learn, which is a subset of AI. It is important to note that not all the smart systems have the ability to learn. One typical example is Shadowloo. Shadowloo is a rule-based chatbot developed by MIT in 1960s. Shadowloo relies only on a set of human-defined rules to reply to customers' queries within a limited domain. Shadowloo is an example for the use of artificial intelligence without machine learning. Shadowloo is in the following red region, which belongs to AI but not involving machine learning. Scientists have provided a special name for the AI techniques without machine learning. They call them Gulf AI, that is, good old-fashioned artificial intelligence. Shadowloo is a Gulf AI. Shadowloo was initially developed by Terry at MIT in 1960s. Although it is a rule-based AI chatbot without involving machine learning, it contributes to the major advancement in the evolution of natural language processing. Terry is now an emeritus professor at Stanford. This picture shows Sherry uses a set of pre-programmed rules to carry on simple conversations about a set of blocks on a table. The following is a demo showing how Shadowloo works in response to human instructions. Firstly, a person gives an instruction. Find a green cylinder. Shedulu searched this instruction in his knowledge base and finds it. Then he answered OK and moved to the green cylinder. Now the person gives another instruction. Move it to the right. Since this instruction is also in Shedulu's knowledge base, it is down. Next, the person gives a similar instruction. Move it to the left. But this time, Shedulu has no idea and said, I don't understand what you mean. Because this instruction is not in the Shedulu's knowledge base. From this example, we can see that it is the human-defined rules that make Shedulu answer questions and assist customers to a limited extent. In the whole process, no machine learning is required. Shedulu received its intelligence only by a large amount of knowledge by human inputs. Therefore, Shedulu is a Golf AI. In comparison, Boston Dynamics robot, Atlas, is an example of AI with machine learning. As opposed to the rule-based systems, such as Shedulu, that cannot update on its own, Atlas can learn from mistakes intelligently. We can see from this video demo, even when the position of the box has been changed, Atlas can still relocate the box and attempt to pick it up. Atlas's advanced machine learning technologies and state-of-the-art control systems give himself the power and balance to demonstrate human-level agility. Having learned the relationship between AI and machine learning, we know that machine learning is a subset of AI with a focus on the AI systems that have the ability to learn. But how about neural computing? We are now ready to study the relationship of neural computing with machine learning. Neural computing refers to brain-inspired machine learning methods that use the networks of neurons to learn. It differs from machine learning in that machine learning can use not only brain-inspired methods, but also any other statistical methods to give computers the ability to learn. Therefore, neural computing is a subfield of machine learning. It is worth noticing that statistical methods contain many different mathematical models and technologies that have been used for information extraction. This is a wide concept, and a neural network is just one of them. A machine learning method that is not based on neural networks does not belong to neural computing. Now, I have a question. Can you provide an example for the use of machine learning without neural computing? To answer this question, we can think about any machine learning model that does not use neural networks. For instance, Support Vector Machine (SVM) is an interesting supervised learning model for data classification. The goal of SVM algorithm is to find a plane, known as a decision boundary, which has the maximum margin to classify the data points into different categories. Let's take a look at this simple example to see the basic intuition behind SVM. Suppose we have two classes of data points, bees and ants. To separate bees from ants, there are many possible plans that could be chosen. The goal of SVM is to find a plan that has the maximal margin between two classes. In this example, the red plan can be one possible choice. But SVM will not consider this plan, because the yellow margin between the two classes is not maximized. Instead, SVM uses linear algebra methods to find the green plane Wx equals b, because the margin with the green plane is maximized, which is equal to 2 over the norm of W. I will not dig into the mathematical details of SVM. One point we should pay attention to is that in SVM, the method of determining the coefficients W and B for this green plane is based on linear algebra rather than neural networks. Thus, SVM is a supervised machine learning method, but not neural computing. It is worth mentioning that neural computing can also perform the classification task, but in a different way of SVM. Neural computing applies a network of neurons to parse data, learns from it, and uses the learnings to discover meaningful patterns for classification. Note that if the classification plane is not a straight line but a curve, we call it nonlinear classification problem. For nonlinear classification, SVM and neural computing also use the different approaches. SVM uses a kernel function to map samples to high-dimensional feature space, whereas neural computing uses a nonlinear activation function of the neuron in the neural network. Despite using different models, machine learning and neural computing have a lot of similarity for supervised learning. In machine learning, we load the training data and use machine learning algorithms to train statistical model for new input data prediction. In neural computing, we fed the training data into neural network and use a set of learning rules to train the neural network for new input data prediction. Comparing these two models, we can see that machine learning uses a statistical model to learn from examples, whereas neural computing uses a neural network to learn from the samples. In addition, in machine learning, the process of determining the statistical model is called machine learning. In neural computing, the process of determining the neural network is called learning rule. We can implement the models of machine learning in different ways, and the neural network is one of them. Due to the close relationship between neural computing and machine learning, here comes the question: which one is better, neural computing or machine learning? Indeed, this is a highly arguable question. Scientists from different research areas may have different opinions. However, most of them agree that the choice between neural computing and machine learning depends on the data and the problem we are trying to solve. In general, if we have good hardware, such as high-performance GPUs, and the data to be processed is on a very large scale, then it is better to consider using neural computing. Otherwise, consider machine learning. Apart from hardware and data size, the choice between neural computing and machine learning can also depend on the requirement of manual guidance during the training. If we don't want to manually extract features, we can consider using neural computing. Otherwise, we can choose basic machine learning. To be more specific, basic machine learning models sometimes still require some guidance from a data scientist, such as manually creating or extracting features for image recognition. If a machine learning algorithm returns an inaccurate prediction, then an engineer has to step in and makes adjustment. However, in neural computing, the features are extracted automatically, and the neural computing algorithm learns from its own errors. We don't have to know which features are the best representation of the object. A neural computing algorithm can determine on its own if the prediction is accurate or not through its own neural network. For example, for car recognition in this video, the traditional machine learning algorithm requires a software engineer to manually choose features and a classifier, say SVM, to sort images. In comparison, a neural computing algorithm can extract these features automatically and learns from its own errors. We skip the manual step of extracting features from the images and feed the images directly into the neural network to predict the object. We can see that the two stages in machine learning, feature extraction and classification, have been merged into one neural network in the neural computing. This neural network not only can automatically extract features, but also can do the classification without any manual guidance from the software engineer. In summary, we show the following table, which is the guidance for our choice between neural computing and machine learning. If we would like to choose our own features for extraction, we can consider machine learning. If our training data is very large, we can consider neural computing. The training time for machine learning is short, while it takes longer in neural computing. However, the accuracy of neural computing is higher than machine learning. In practice, it is often advantageous to use both techniques as a combined approach, since neural computing is a subfield of machine learning. Now let's summarize. In this section, we have learned the difference among AI, machine learning, and neural computing. AI is a very general and broad concept, which refers to any techniques that make computers smart to mimic human behavior. Machine learning is a subset of AI, which focuses on making computers to have the ability to learn using statistical methods. Neural computing is a subset of machine learning, which is brain-inspired, and uses neural networks to learn. When the layers of neural networks is increasing, this becomes deep learning. Deep learning is a subset of neural computing, which uses deep neural networks to build the hierarchical of data presentations. Here, the deep means multi-layer neural networks, with usually 3 or more layers. There are 2 examples that are worth noticing. One example is Shadowloo, a rule-based chatbot, which is an AI application but without machine learning. Another example of machine learning but not neural computing is Support Vector Machine, SVM. We have also learned how neural computing and machine learning are related, and how to choose between them.